Please listen to this lecture and follow along by reading the PowerPoint as I read it aloud. This is Unit 2, Section C, Part 2. We're going to continue with oxygen therapy this week. Our reading assignment for Section C, Part 2 is Chapter 56, pages 1291 through 1295. Today I'm going to talk about and discuss the 3 supply methods for home oxygen that you're usually going to see if you're out in the home care setting and even sometimes in the SNFs. Those facilities and in home care, they do not have access to the PSI source like we would use in the acute care setting. Usually you're going to see some type of setup similar to what we have listed here: compressed oxygen cylinders, liquid oxygen systems, and oxygen concentrators. So throughout this PowerPoint, I'm going to discuss the 3 different types of methods you would normally see in the home care setting or alternative settings. The first type of delivery device that I will talk about is the compressed oxygen cylinders. This is the one that you usually see even in the acute care setting. It's the E-tank. It has a regulator at the top, and in some facilities you may even see the easy used regulator, which is called grab and go. You just kind of turn the top and then you can go, and you don't have to worry about having a key to attach the regulator to the tank. So compressed oxygen cylinders is the primary used in alternative care settings for ambulation or as a backup system for liquid or concentrator supply systems. A lot of times, depending on the patient's oxygen needs, they may have an E-tank that they put inside of a holder with wheels on it, and they take it with them when they go out and about to the grocery store or church or whatever it is they're planning to go. Of course, they will have to calculate and figure out how much oxygen they will need for the errands or the trips that they're taking, because they do not want to run out prior to coming back to their home. So it's important for patients and their family to be familiar with the safety practices regarding the use of cylinders. In the home care setting, the home care supplier, like I said in the last lesson, will go up to the hospital and teach the patient about the oxygen, how to put the regulator on, give them a cannula, and then usually they will meet them in their home. They'll have extra supplies of tanks or the concentrator or whatever it is that they need, and then they'll also educate them again at that point. So for the compressed oxygen cylinders, in addition to the cylinder gas, a pressure reducing valve with flow meter is needed to deliver O2 at a prescribed flow. So standard flow meters, as you are aware, because you see them in the hospital, most of them go up to about 15 liters. Flows used in the alternative settings are typically between a quarter of a liter to about 5 liters. Usually you don't see a patient go home with more than 5 liters. They have not standardized a type of high flow system for home. It just doesn't have the source of the pressure needed to maintain one, but they are currently working on some type of prototype for that, but it's not nothing concrete. So if a person needs more liter flow than 5 liters, you usually do not see them go home at that point until we're able to wean them down. Some devices like a dose puff type of oxygen device, theirs are already preset, and the patient does not have to worry about making changes to the oxygen or whatever flow that they need. They just turn it on and it's ready to go. However, for this reason, the RT should select a calibrated low flow flow meter or a preset flow restrictor, depending on the patient's need. Now I'm going to go through some advantages and disadvantages of the compressed oxygen cylinders. So for advantages, one thing that is great is the fact it's good for small volume use, no waste, no loss, stores oxygen indefinitely. You don't have to worry about it leaking too much. And it's very available and it's portable. So like I said before, you can put it in a tank holder and take it with you without any trouble. It is kind of bulky if you have the big tank, but you can be pretty mobile. Some of the disadvantages of it, cylinders are very heavy and bulky. You have to use safety precautions when you're storing it. So there's always a safety hazard. You can't like put them in your garage if it's going to be a really hot day. You put yourself and your neighbors at risk of explosion and things like that if it gets too warm. You only have so much gas volume in the tank. So as I have stated previously, if a person was to go out and run errands, etc., they need to be able to calculate how much oxygen, or at least estimate how much they think they will need for their trip. It requires, because it's only so much in the little cylinder, frequent deliveries and tight valves and stuff like that, because you don't want to leave it running and then it seep out, etc. So it's just a few things you need to think about, but this is a couple good listings of advantages and disadvantages to consider. So in this picture, you can see the top of an e-cylinder. Let me see if I can point out here a few things. Okay, so the top of this, we have the regulator, pressure gauge manometer that tells you how many pounds of oxygen that are in it. Here you would set the flow, whether it's 2 liters, 3 liters, 5 liters. You usually do not use up to 15 liters in a home setting, but some patients do get a little ambitious when they're very short of breath and they will turn it up. We do not encourage them to do so. Here's where you would attach your oxygen device, the nasal cannula or type of mask if the person's using a mask. Here is the little handle to attach and detach the regulator. And up here at the top is where you would turn on the gas to actually turn on and pressurize the regulator for the PSI. Next, I'm going to talk about liquid oxygen systems. This particular system is very costly, and it's one of the system of choice for a high volume oxygen user. So someone who needs a lot of oxygen requirements as far as the frequency of oxygen usage, this will be more ideal for the person. However, it does cost more than a typical oxygen tank. The nice thing about this is it can store large quantities of oxygen in small places. Matter of fact, 1 cubic foot of liquid oxygen is equivalent to 860 cubic feet of gaseous oxygen. So most portable units come with a carrying case or small cart, and it's very ideal for an ambulatory patient capable of physical activity. When I worked in long-term care, it was a subacute hospital or clinic or long-term facility where the patients actually lived there, ventilator patients. I also took care of some patients that were not on ventilators. And what I had to do, one of my duties every morning was to go out to the oxygen shed. It was a big old tall oxygen container that had liquid oxygen in it, and I would take these little small portable oxygen containers and I would fill them up. I would flip them over and compress them into the big tank, and it would fill up my little small ones, and then the little small ones were the ones we took back into the facility for our patients that can ambulate around the hospital or the clinic or living facility SNF and do their activities for the day. So it was my job to do that every morning and make sure I filled them up for physical therapy, or if the patient just wanted to go to the dining area or do activities, they used the little portable one. It was almost like a purse that kind of went over the shoulder, and then the oxygen cannula will be attached to that. It was kind of neat. It was very unique to go out there and use the liquid oxygen. The liquid tank was covered in frost, and the oxygen inside was very cold. There was a lot of it. Very interesting. So the liquid oxygen systems, depending on the manufacturer or model, can hold up to 45 to 100 pounds of liquid O2. A lot of oxygen. Typically, portable units, like I said before, the little purse strap thing was about 5 to 14 pounds. I never remembered it being very heavy, but you know, it was something bulky you had to carry around. And those little units can provide 5 to 8 hours of O2 if you're using the typical 2 liters per minute. Of course, if your oxygen requirement was more than that, you would go through the container a lot faster. Uses either adjustable flow restrictor or Bourdon type gauge for a flow meter. So if you were trying to calculate how long the little system would be able to hold enough oxygen for whatever the patient needed based off their liter flow, Here's a calculation that you can refer to, at least part of it, and we're going to look at another one on the next slide that kind of gives you an idea how you should go about figuring out the duration of flow. So first, to calculate the duration of flow, you're going to convert the weight of liquid O2 to pounds to the equivalent volume of the gaseous O2, and you're going to change it to liters. So at normal liquid cylinder operating pressure, 1 pound of liquid O2 is equal to 344 liters of gaseous O2, and that's the factor you're going to use to do your calculation. Okay, so in this slide we have a mini clinic problem for us to kind of figure out the length of flow that will be needed for a patient who is going to be traveling with liquid oxygen. So in this table, the problem says a home care patient receives a nasal cannula O2 at 2 liters per minute from a 100-pound liquid O2 system. The system gauge indicates that the cylinder is half full. Approximately how long will this system last until it's empty? Well, first you're going to do step 1. You're going to compute and find out how much available O2 do I have left in the system. So we know it's a 100-pound system, but it's only half full. So you're going to take 100 times 0.5, and that equals 50 pounds. Second step is to compute the available gaseous O2. So what we're going to do is take the 50 pounds that we know is available, and we're going to times it by that factor that I talked about on the other slide, 344 liters per pound, and that equals 17,200 liters. That's still quite a bit of liter flow left to use. The third step is to divide the available volume of gas, O2, by the prescribed liter flow. And there is the formula there to figure out how much oxygen would you have left based off of 2 liters of flow. So according to the formula, after you put in the factors, 17,200 liters divided by 2 liters per minute, that equals 600 minutes of flow that you'll be able to use, which equals 143.3 hours. So that equals to about 6 days. So you have plenty of oxygen inside the O2 system to last for a while. Next, I'm going to talk about the advantages and disadvantages of using a liquid oxygen system outside of the fact that it's very expensive. Some advantages, it provides large volumes and low pressure system capable of filling portable units from a main reservoir and is good for rehabilitation. Like I was saying before, my job at the SNF was to go out every morning and fill up these little portable units for the patients and residents to use. So it's very useful to use for that reason, because the liquid oxygen systems can hold a lot of O2, and that's great for a facility that does not have piped in oxygen. Some of the disadvantages outside of it being so expensive is delivered as needed. Loss of oxygen because of the system vents, so it seeps out after a while. You have to kind of readily use it. Low temperature safety hazard, critical temperature of negative 181 Fahrenheit. Low pressure is not a 50 psi source, and sometimes the portable units can be difficult to fill. In this slide you can see a type of liquid oxygen portable system. It's kind of a blast from the past for me, because it's exactly what the unit looked like when I would go outside of the subacute nursing home to fill up the tanks. So let me see if I can kind of point out here how the tank works. So you got the reservoir here that holds the liquid oxygen. They also have a little thingy here at the top that my little portable tank would connect to, and I would have to push down really hard, and when I would push down on that little opening, the valve, it would fill my tank, and I had to turn my little tank container upside down to connect like a puzzle piece into that area. If you're not using it for that reason, you want to use it more as a other type of oxygen source. It does have a little nozzle here that you can connect other devices to it and use oxygen that way as well. I believe this down here is just as a picture of the portable system. As you can see the top of it, it looks like a puzzle piece, and that's what I would flip upside down and connect to my liquid oxygen system at the top here. Very interesting. Here are 2 more examples of a couple portable systems. As you can see, it's the Puritan Bennett model. The one you can actually see how small it is by the way it sits in the person's hand. And this unit right here, the Puritan Bennett Companion 1000, this is one that's very similar to what I used in the SNF subacute setting. Okay, the last system I'm going to talk about is the oxygen concentrators. This is what you will see commonly in the home care setting. The thing that makes it very useful and popular in the home care setting is because it can be used with electrical power. A lot of times the patients in the home setting will have like 50 feet of oxygen tubing so they can walk in and out of their home. One thing that's very nice, you don't have to worry about running out of oxygen because it has its own mechanism on the inside to regenerate its own oxygen. So I'm going to kind of talk about that a little bit here. So the electrical power devices, it separates oxygen from room air, so you don't have to have a tank or anything. Most concentrators extract oxygen by a molecular sieve. The oxygen is pumped, filtered, compressed, and separated into sieves containing sodium and aluminum silicate pellets. The pellets remove the nitrogen, carbon dioxide, and water vapor. So one sieve is pressurized to store oxygen and the other is depressurized to remove the nitrogen, carbon dioxide, and the water vapor. So when we're using the oxygen concentrator, the concentration that the concentrator delivers is a little bit different from what we would get from the wall pressurized oxygen in a hospital setting. So if you was to take an analyzer and you was to analyze the concentrate of the FiO2 that comes out of a concentrator, it's a little bit different. It delivers 1 to 2 liters per minute, and if you was to use the analyzer, you would only get about 92 to 95% concentration from the concentrator. If you had a greater liter flow of about 5 liters or greater, the FiO2, if you use the analyzer, is only going to be about 85% to 93% concentration. So it's a little bit different. Delivered FiO2 below 85% will usually indicate that the filter on the concentrator needs to be cleaned and replaced. So if you used to take an analyzer and you used to put in, I don't know if you remember doing this in your procedural 1 class, you would take a bag and put a tubing in there and you would turn the liter flow to whatever it is you want it to be, and you would put an analyzer in there to kind of analyze how much oxygen you were getting. So if you used to do a analysis, a calibration or whatever of the oxygen concentrator, and you was to get an FiO2 less than 85%, that indicated that you need to do a little maintenance on the concentrator and check the filter and clean it. Out of all of the oxygen systems that we've talked about for this lesson, the most cost-effective supply method for patients in the alternative care setting who need continuous low-flow oxygen is an oxygen concentrator. If running 24 hours a day can increase average monthly electrical bill by 5% to 10% overall. Heat given off can also affect energy usage by increasing the room temperature as well. That's why they have the little ventilation system on the side of the concentrator. If you have a chance and you think about it when you're in class, we have concentrators in our stock room. If you want us to pull one out and show you, I can gladly show you one. And I also have a video on the usage of the oxygen concentrator as well. So when we're looking at oxygen concentrators and advantages and disadvantages, well, an advantage, there's no waste or loss. It can be used as a low pressure system. It's very cost effective and you don't have to worry about running out of oxygen or waiting for an O2 tank delivery. It generates its own oxygen. One of the disadvantages is the unit depends primarily on electricity, well, pretty much all electricity. You will need to have backup oxygen in case your power is to go out. It cannot operate ventilators, so you don't have a PSI port and things like that. If you use a concentrator with a ventilator, you would have to use a pressure line adapter to tee in oxygen into your ventilator, and that will be in liter flow, which is very common in the home setting. Increased flows equal decreased FiO2, and of course, as I said before, using a concentrator nonstop will increase your oxygen, not your oxygen bill, but your electric bill. In this this is a diagram of the inside compartments of the oxygen concentrator. So you can see here, this is where it will draw in the room air, and here are the molecular sieves that kind of does this thing to transform the room air into oxygen. And then here is the bacterial filter that if it gets clogged would need to be replaced because it's affecting the FiO2. And here is the pump that works with the sieves to kind of get out the CO2 and nitrogen from the air and generate the oxygen. So in this picture, I just have a few examples of some oxygen concentrators. The one at the top, the DeVilbiss 3-liter concentrator, looks very similar to the one that we have in our current lab, or we have a very similar model. And then here's another type right here, the 1 system concentrator. And then we got Respironics also has its own concentrator. In this slide, you can just see all the different types of supplemental oxygen systems, how well they work, how easy they're able to operate. And you need user friendliness when you're dealing with a patient or a family member, because a lot of them, they don't understand a lot of things. So the easier you can make it for the home setting, the better. And then they also have another section called quiet operation. That's very important because in a home setting, you don't want devices that are very loud and disturbing, put it like that. You want something quiet where you can barely hear it humming. And most of the time in a home care setting, the devices are very quiet and when they run. So you can compare and contrast what will be the best type of device based off of what I have here in the chart. As I said previously, the advantages and disadvantages of the 3 types of oxygen systems we've talked about. Here's a whole listing that you can also refer to. And this talks about the compressed O2 system, advantages, disadvantages, liquid O2 system, advantages and disadvantages, as well as the O2 concentrator to review. Next, we're going to talk about problem solving and troubleshooting. So when you're problem solving and troubleshooting, verbal instructions should be reinforced by providing simple written instructions for reference. Anytime we have a patient that go home or they're going to be using home services, and we as RTs have to give direction. Not only we do the hands-on direction, but we also give them a reference book. If you do not have a reference book handy, you should always go to your department and ask your immediate supervisor. They usually have an educational cabinet of some sort where you can give the information to the patient, kind of flip through it and review it with the patient. So the clinician should always confirm and document the ability of the caregivers to use the equipment. That's just kind of a liability thing. You should write down in the patient's EHR, I have reviewed whatever technique or whatever equipment you're using. Write down whether or not they did a return demonstration, how well they did that demonstration to show competence. And the ability of the caregivers and patients to give appropriate return demonstration on the proper equipment usage should be recorded, as I said before, just to make sure it's documented, because this always happens. A patient will go home and maybe they kind of fumble over something or don't remember how to do something, and the first thing they'll say is, oh, no one ever showed me. But then you will have documentation written down that yes, I did show the patient and they did demonstrate back to me the proper technique in case it ever goes further, if there's a major incident that occurs as a result of it. With the instructions that you're going to give, you're going to inform the patient or caregiver that they should check all O2 delivery equipment at least once a day. In the home setting, a checklist form can help ensure that the patient's important tasks are performed regularly. And that's if you're one of the techs or staff that are working in a home care setting. They have their own protocols and routines that they follow. But you always want to have some kind of reference sheet to give to the patient or family member, because they forget how to do things, just so they can kind of go back and check. Clinicians should ensure that all O2 supply systems have an emergency backup supply, either H tank, K tank, or E cylinders, as stated previously. So when we're looking at hazards that can go on, you have to make sure that the patient has a proper securing device for their cylinders. You don't want to have unsecure cylinders, because if the head of those regulators was to get popped off, it could be a bottle rocket. So, to avoid that happening, you have to make sure you have proper holding areas. Ungrounded equipment can be a hazard because it can cause electrical issues. Mishandling of liquid can cause burns with oxygen and fire. Bacterial contaminations of nebulizer or humidification systems can be an infection control issue. So we always want to make sure that we tell the patients, especially if they have like nebulizers and things like that, that are attached to their oxygen system, or bubblers, the little bubblers that go on, the proper procedure for handling and changing and decontaminating these devices. Inaccurate O2 flows or concentrations can occur. So it's important and imperative that the supplier come out and calibrate this equipment like they should monthly, to make sure that the FiO2 levels can be confirmed that the patient is getting what they're supposed to in the home care setting. So as stated previously, the routine maintenance is imperative and necessary. We have to make sure that the equipment is properly cleaned. There's replacement of filters, checking the alarm system on the device if it requires that, confirming FiO2 levels by using the O2 sensor or analyzer as stated previously. This ends Unit 2, Part 2 of Oxygen Systems.